Good evening, sir. Smart. So I want to ask that. I hope.
So, please go ahead.
Oh, good evening, everyone. Like today's section, we'll be talking on quantitative summary and data visualization. So I think last week we did a proper introduction to her by going through the environment, the R environment, and going through, taking you through the R environment and basic rudiment to programming. So today we'll be going to how to summarize your data, make sense out of your data, and how to visualize your data. So I'll be sharing my screen right away. Let me see. 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 So please, can you confirm if you can see my screen? Yes.
Not yet, please.
Not yet, please.
Okay.
Yes, I can see it now.
Yes, it's up now.
Okay. Okay. So I don't want us to waste much of our time. So if you have been working previously on R, I will just want you to just run this code so that you can clear all your cursor and everything. Just you can clear the list, the variables at the environment. Rm list equals to ls parentheses and okay. So now you can have an empty. You will have an empty environment. So so and please ensure you are working with the right working directory, because if you are not working with the right directory, you might trying to run this code or importing your data set, you might run into error and all this stuff. Just check if you are working with the right directorate by clicking on get wd, that's get working directorate, and know the working directorate you are working with. And so from there you can start, and you notice if you have your data set in that particular directorate or not. If you don't have your data set in that particular directorate, you can change your directorate by coming to set directorate. So then you will navigate through. You can choose it through by setting your work rate. So we are going to we are going to of central tendency, measures of central tendency. So I'll be loading the data set called the heights data set. I think everybody have access to that data set. It is CSV format. We have it in CSV format and SAP format. That's SPSS format. So the last class, I thought I bring import your data set from some your data set in any form. I thought from CSV, from I think from Excel, and from SAV, which is SPSS. So now this data set is in SPS CSV. So we click, we load the read R first, which is the library that is sufficient for loading, for bringing, for importing the data. If you do not load the library, you won't be able to have access to the data. So now running this code, read underscore. So I'm writing this data name to be HT, that is short form of height, HT. So We are going to use the function read. Just type the function again. So you can see it, read underscore CSV. Then, if you are working in the right directorate, you can easily say it.csv. Yeah. So you can neglect this upper part. You can neglect this upper part. But if you run it this way, it's still the same thing. If you run it this way, it is still the same thing. And if you still since you are not fine with that underscore, you can use read.csv, then it.csv. It's still the same thing. And probably if you do not know the name of the data set you are working with, you can easily do it this way. Just read underscore or dot CSV, as the case may be. Then you choose files. So once you click on choose file and you run your command on choose file, it's going to open that your folder. Like, then you can navigate through and look for the data set you are looking for. But I won't advise you to use this, because if you are working on an existing project, like you have an existing data you're working with, so you close your R and you want to continue, you have to select again and go back to that. You are still going to go and choose that file again before you start. But once you save your data set like this, you have it like this, you don't have any issue. So at any time you can just start working on R. So you can write all this into a variable. So I code this data set for this class to be ht. So this is it. We have the data called ht. So if you want to see the headings, like the first few rows in the data set, like you want to take a glimpse at the structure, just have to click on head. You are going to use the head function, head, then you pass the name of the data set into the command. We are going to see the first. It's going to show you the first 6 at default. Once you use the head function, it's going to show you the first 6 of every data set. So it's depending on you. You can limit the observation you want to see. You can limit it to 3. You can limit it to 2. You can limit it to 10. So once you want to limit it, you're going to say n equals, that is observation you want to see, equals, let me just use 10, equals 10. It's going to show 1 to 10. It's going to show 10. So you can limit it. You can increase it as the case may be. So you can look at the bottom of a data set as well, the last few observations, by using the function called, the command called tail of your command, and just run it. So these are the last 6. Hello, please. Hello, can you go on?
Yes, please. Actually, I don't know. I think I'm not the only one, but following has been a bit difficult. I don't know if you could.
You are not alone. It's quite fast and it's difficult to both listen and follow up with what you're doing, please.
That we can be following along, and if possible, maybe have an hands-on with the data we have. Thank you.
Okay, thank you very much. Thanks for the observation.
Please, I have a comment. I noticed that the data set in the classwork, I can't see any data set named height. And I've been wondering where these data sets came from. Is this something you have arbitrarily with you? The data set you have in the classwork is menopause.csf, resident doctor.sls, BP trial, ion trial.
Sorry, height is part of the data. Height is part of the data because I actually got this from the course material.
Height.
Yes.
Except other people.
Okay,
there are just 5 data sets in the classwork, and height is none of it.
Yeah, I checked. I didn't see the data set.
I think it's
Coming,
there.
someone.
I from there, so.
And it will be a bit difficult for us because we won't be able to follow you if you don't have that data set. That's my own opinion.
Okay. What data set do you have? Like, what data set do you have?
The data set in the classroom includes menopause.csv, BP trial, resident doctor, Freetown SBP, and ion trials.csv.
Okay. I know what to do. Just let me load the resident doctor and use that as an example.
Okay.
But you can check in your course material. I think the data set is going to drop now. Yeah, the height data set is going to drop now. So sorry for the inconveniences, please.
Okay, so we should check the classroom.
Yeah, probably after this class, it's going to drop. Let me just load the resident. Right. Please, can you off your mic? Doctors. Yeah, I think I have it.
Please, could you continue with the one, or you are changing to resident doctor?
Yes, I've changed to resident doctor.
We will download that.
So now you can load the resident doctor. You can load the resident doctor. But I think if you check your course material now, you are going to see the height variable. You are going to see it there. So I said something. I said, once you have any data set, you might want to look at the structure of the data set. When we talk about structure of the data set, the variables in the data set, the names of the variable in the data set, the first few observation in the data set, and the last few observation in the data set. So I have loaded this resident doctor data set. I want to see the first few observation and the names of the data and the names of the variable in this data set. So what I'm going to just do is head of RDX. Can you see? It's showing me the first 6 observations at default. Once you use the function head for any data set, it's going to show you the first 6 observations, the first 6 rows in that data set. So, and it's showing me the columns, like the variable names in the in any 2-dimension. Let me just say, okay, in any 2-dimension table, we have the column and the row. So the columns are variable name, while the rows are the the observations. So it's showing me the variable names, which are age, mental health score, job satisfaction score, workload score, age category, marital status, children, female, and houseworked. So I can get the names of this observation by using the names function, names of RDX. So it's going to show the names. Can you see age? So you can see the name. This is the name. So I said you can limit at default. R is going to show you the first 6 rows, the first 6 line of the observation. So you can limit this the output R is going to give you to probably, you can limit it or increase the number of observation you want R to give. Okay, let me say head equals to RDX, n equals, let me just say 3. You are going to show me the first 3 observation. This n shows that, hey bro, I want you to show me the first 3 observation in this data set, including the headings. So, and you can increase it to 10. You can increase it as many as it is. So So you can also look at the tail, like the last few observations in the data set, by using the command called tail. By using the command called tail ht, it's going to show you the last 6. Okay, I'm coming, not ht, we are working with RDS, sorry, RDS. So it's going to show you the last 6 observations with, let me show you the output. It's going to show you the last 6 observations with the headings. So you can also limit this, and you can increase it by saying tail RDX n equals 3. It's going to show you the last 3 observation, or n equals 10. It's going to show you the last 10 observation. If you want to know the number of observation, I mean the rows in a data set, we are going to use n. We are going to use the function called n row. Then you pass out the s. So it's going to show you the number of observations. It's going to show you the number of observation in the data set. So it shows that we have 161 observations. That is the number of resident doctors that answered. Probably if it's a survey, the number of resident doctors that we have their details is 161. 161. That's what it means. And you can as well know the number of variables. The number of variables in the observation. We are going to use n column. N column. Once you use n column, then you pass RDX. The data set is going to show you have 9 columns, 9 variables. That is 9 variables once you count the variables. So if you want to check the number of rows and columns together at once, there is a function we call dim. It's just like telling me dimension. Let me just say the short form of dimension. Dim of RDS. You see, the number of observation will come first, and the number of variables will come last. Can you see? 161 observations and 9 variables. So please, did we get that? Am I too fast? Did we get that? Like, did we get that? Okay. Okay.
The only difference I had from my own to yours is that mine says there are 10 columns, yours says 9. So maybe we are still talking about different data.
Exactly. Yes, I actually have like this data I'm working with actually was, we trained cohort by cohort. So I have this data already with me. So when you said resident data, I have them saved already. But still yet, I don't know if I can, because if I said I should go and get
I'm just letting you know that there is a difference between what we have and what you have, so that when we start getting values that are different, it's okay.
Okay, please. I'm going to ensure I have the updated data, and we keep you guys like updated. I'm very, very sorry for these differences. And in case you are experiencing similar thing with Miss Olabisi, please, you can just and it means the same thing. The basic idea here is just understanding what those functions are meant for. That's just the basic idea. You can work with any data set. You can work with anything you like. You can work with anything you like. You actually like. So now we have something we call structure. Checking the structure of a data set. Checking the structure of a data set. So if you want to check the structure of your data set, we are going to use XTR. Yeah, XTR. It stands for structure. Just like telling, hey bro, I need the structure of resident doctor data. So it's going to show you the structure. The structure is going to tell you the number of observation, the number of rows, and the number of variables, the type of data the type of variable each variable is carrying, and the names of the variable in the data set. So it's telling me that we have age. When you look at this, okay, starting from first, it's telling me the data set it's a data frame actually. It's telling me that we have 161 observation of 9 variables, age, and the data is integer. It's integer. So once you come down, you're going to see it's telling me that when it comes to workload score, it's telling me that the type of data is numeric. So when it comes to this age cards actually is 8 categories. It's telling me that the data set is character data. This also is telling me that this data set is character data. So that's what the structure function does. So here is a recap. We have the head to show the number of the first set of observation. We have the tail to show the last set of observation, the bottom, and the last set of observation. We have the dimension to show the number of observation and the number of variables together. We have the end column to shows the number of variables we have. We have the end rows to show the number of rows, and we have the structure function to show the structure of the data set. So now I think we can move to measure of central tendency, which are the mean, median, mode, and what are they calling it? And others. Let me just say and others. But these are the measure of standard deviation is the mean, median, and mode. So standard deviation is actually measure of
mean.
Yes.
Sorry, instructor, please, I have a question.
Okay, can you go on?
All right, you said it shows the different types of data in the variables. Please, and you mentioned integer and number. What's the difference between integer and number, please?
I seriously, I knew someone we asked this question. So integer are numbers. They are all numbers. They don't have fractions. I don't know if you get. They are all numbers. They are just, let me just say, they are discrete data. Discrete. We have two type of quantitative data. We have discrete and continuous.
Okay.
Do you get? So
yeah.
Once it comes to R, once you see this thing, once you see integers, they are whole numbers. So once you see numeric, that shows they have decimal, they are continuous. Some of the data might be continuous, some of the data might not be continuous. I'm coming. Let me prove this. Okay, let me just do this like this. What's the name of this data set? We have work score load. Can you see? I call out the data set that is showing us now. I see they are decimal numbers.
Yes, I can.
So once you call out the other one, I'm coming. The other one. Which one was giving us? Let me check the structure again. Which one was giving us the integer? Okay, the h. H cannot be in decimal now. H cannot be in decimal. The only time H can be in decimal is when it is measured with respect to, let me just say, with respect to time. Yeah, when it's measured with respect to time. When they say someone has spent 100 and something days, something minutes, and something seconds, milliseconds like that. That's when it can become a continuous data. So I think I've answered your question.
Yes, you have. Thank you.
So going to the measure of central tendency, we have the mean, the median, and the mode. So generally, we have something we call descriptive analysis. Descriptive analysis. Measure of central tendency is like, it's just, let me just say, it's just discrete in nature. Both measure of central tendency and standard and measure of dispersion, standard deviation, variance, range, all this one, they are discrete in nature. The two, they are discrete in nature. They are discrete in nature. They describe the data set. They just describe the data set. That's why we have the mean function, the max function, the all this. So let's get started. I'm going to use the RDS data, which is the resident doctor data. So, and the age variable. So let's start with mean. This is mean. So the age. So you are going to see we have an average. Once you want to use the mean, there is a function. You pass the variable, the data set name into the function called mean, RDS, $, then mean. So it's going to show the mean value for that variable, the average value of that variable actually. So we tend to like, okay, I know someone might be imagining that why are we using $? Actually, we are telling R, the reason why for $, is that, okay, when the variable name RDS, if I say RDS, it's going to bring the whole data set. But I need a particular variable in this data set. So how will I call a particular variable in this data set? Is by merging it with and connecting it with a $. That is, I'm telling him that in this RDS, in this resident doctor variable data set, there is a variable called age. I want to look up to. So then you can call out your age function. Or other way around, you can do RDS. I hope I get it. Yeah. I hope I get it. I'm coming. Yeah. So once you use this RDS into a cube bracket, comma 1, you are telling R that it should bring the set of observation 1 in variable 1. Once you click on 2, you change it to 2. You are telling him to bring the set of observation in variable 2. I don't know if you get. Okay. Once you change it to 3, you are telling him to bring the set of observation in variable 3. So you can use that too as well. If you want to call out your row, you can check your row by using RDS Q bracket, this Q bracket 1. This means the first variable and the first observation. This means the second observation. This means the third observation. Only the third observation. So why? Okay, if you want to check the, let me just say, set of variables, like variables are more than 1, you can just say RDS into bracket, into this Q bracket. We're going to use the word combine, which is C, into bracket C. I hope I get it here. I hope. Is it wrong? Yeah. I'm telling R now that I want to get variable age and job satisfaction. Looking at this, so you can use this to select the number of variable actually you want to really work with. I'm coming. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let me get the last variable as well. I'm going to say 9. Can you see? That is, you are selecting the data set you want to work with. This is what we call subsetting in R. you are looking at the data set, you are kind of selecting the data set. So what about if out of this 9 variable, you just want to omit just one. You want to omit one variable, just one variable. It is improper for you to start saying select 1, select 2, select 3. Since I want to omit, let me just say I want to omit the 8 variables. The 8th variable, I will just like say -8. So it's going to bring all the observation minus the last observation. I think I've explained where the dollar sign of a thing comes from. So looking at the mean, it shows that the average age of 161 resident doctors is 34.12 years. So which can be round off to 34. That's their average age. Their average age on average is 34 years. What about if you have a missing value in your observation? I'm coming. Let me create a problem. 1, 2, 3, 4, and let me use this. Okay, let me use this. Man. So coming, I don't know if I create a problem. I'm coming, sorry. C, and just write it into M. Okay, so M. So now we have a missing observation in this variable called M. I created another observation to insert a missing value. So we have the observation called M, and you cannot check for your mean when you have an observation that is missing. You will tell R that N, it should remove, okay, NA dot RM. You make it true. You can in full, like in full, or you just anyone you like. So it's going to show the average weight, the average, any average that you are looking for. So that's how once you have a missing observation, that's how you can check. You are going to use RM, that is, it should remove missing. That is true. Remove missing value, guy. Now wait, that's what you are telling me. That guy, Alpha, remove that missing value. I don't have it, so I'm not considering the missing value. I think we can move forward. So what about the median? Okay, go on.
For example, if we in the data set that we have about resident doctor, if for example some ages of the doctors are not available, are we going to say, like the one you created, to say that mean, and we give the assign operator and say, use that example, and then write that even if you're not going to run the code, so that we can understand better.
Oh, okay. Imagine that.
Imagine the variable.
Exactly. Imagine we have a missing variable in the resident doctor. So you are going to say resident doctor $ age R.nm equals true. Then it's going to run. If you have a missing data there, it's going to run. It's going to omit the missing. I hope I've answered your question.
Sorry, I have a question also.
Okay.
Yeah, assuming let's assume that we have like 30 columns, and I want to like know the mean for, like, let's say the first 25. How do I write the code? Will I be writing 1, 2, 3, 4, or is there a shorter way of doing that?
Okay, you want to know you want to know the first 25, right?
Yes, For each column, for the first 25.
Wait, the average weight for each column, all the column.
Yeah, like you were doing something here that, like, okay, let's say this code RDS, the square bracket C139. Is it the same way that I'm going to write for the first 25 if I'm going to do something like for the first 25 in the 30 column data?
In the 30 column data, no. Okay, if you want to check, like, what you're going to do is, I'm coming. First 25, and everything is numeric or either integer.
Yes.
Work that way. Coming. Let me just copy. I want to give a trial. Actually, that's a very technical question. You will have to. You can't run it that way. You have to like specify after each other age.
Okay, 1 to 25.
Yeah. Actually, that's how you're going to do it.
Okay, all right, thank you.
Hello?
Anybody speaking? I can hear you.
Yeah, so I just pasted code. In that might help. You have to create a data set. So you have to subset the data. So you might not be able to choose and say first 25 unless you list it out like he said. But if you subset the data, that you create a smaller data set with only the first 25 variables, then you can do something like column means, right? But the reality is that that's not usually an ideal. I mean, I know people do it, but I don't find it typically useful to just find the means of so many things, right? It's usually like more straightforward to do it one by one, or unless you're running as part of like maybe a long report where you're just going to generate the means and put it out in a report. So it's possible to do, to cut it short. It's possible to do, but it's not what we would routinely do. That's the point.
Okay, thank you.
Yeah. Thanks, Daniel.
Thanks, Dr. Ali, for coming to my rescue. So I think we can move on. So going to the median.
I have a question, please.
Okay, can you shoot, please?
All right. Like the illustration you gave, where you created a column to find the mean, then you have a non-available, that's a non-observation. So should, in case I have large data sets and I want to confirm if I have NA, that's a non-available, how do I go about that? Because I know I think in Python, you have to look for none to be sure you don't have an empty observation or empty record.
Oh, Miss Peace, please can you just hold this question at the very end of this class? Just ask me this question so that I can walk everybody through this particular question, please.
All right, no problem. Thank you.
Yeah, thanks. So I'm going to
yeah, please, I have a question.
This particular question. Okay.
Can I go ahead, please?
I can hear you, please. Go ahead, please.
Yeah, thank you. I said, I don't know if it's just my R, but the name function is not working for me. Like the name that describes, that describes the column. I was just trying all the functions on the dataset. So everything worked for now except the name. I don't know if I just typed name and okay, it's names. Okay, thank you.
You can try it out and you see it works. So I think we can move on. So typically, I know in your class, they might have told you what average mean does, median does, and mode does. So I won't get to explain much what we do in this class. So we have the median, shows the middle value, like the midpoint of every observation, the middle value of every observation. That is, and in other words, the median means 50%. 50%. If you have the median age of 10 boys to be 10, that is 50% of the boys have age greater than equals to that median, equals to that particular that 10 or greater than the 10, while another 50 have age lesser than or equals to that median point, that median value. So let's go to median. I'm still using our age. Yeah. So the median age is 33. That is 50% of the doctor have this, while 50% of the doctors under observation have age lesser than this. So I think, let me check if oh yeah, in case of any missing value, same goes to this. R dot N A dot RM true equals true. It's going to remove, it's not going to consider the missing value. So there is a plus here. R is that R does not have a mode function. A mode. When we talk about mode, like the most frequent observation, the most frequent, the most occurrent, the most data, occurring data, yeah, the most frequent observation, sorry. So R does not have the function. So we have to create a function. I can see someone raising up. Grace, can you shoot, please? Please, Paul, you are raising your hand. Can you go on with your question?
I'm sorry. It was when I asked the question before. I'm sorry.
Okay, please, just of your, please, if you don't have any question, please just don't raise your hand. But if you have a question, you can just raise your hand. So I'm going to see. Mustafa, you are raising your hand. What?
Yes, I do, please.
Okay.
That's subsetting. I don't know. It's not working for me.
What
I
again?
don't know.
Which function?
The subsetting. The square bracket subsetting. Yeah.
Are you sure? Okay. What do you, can you just read out what you have?
Okay. Okay, yeah, I think I found it out. Thank you. I was using the wrong data set name. Thank you very much.
Okay, thanks. So R does not have a mode function. It does not have a mode function. Let me check for the RDS link up with age. You see, it's not answering. It won't answer. It won't, because we don't have a mode function. I think it should bring a type of response. So it's not having a mode function. So now we have to create a function. Okay. Before I go to say we have to create a function. Let me just do this. Once you want to create a function in R, you want to create a function in R. A function, let me just say a underscore fn equals. So I'm going to write function of okay. I want to create a function that is going to calculate the BMI of a student. Once they just input the age and the height and the weight, it's going to automatically calculate their BMI. Just say, so I'm going to need the weight. Let me just use WG, comma, and the HD height. So function body, I'm going to create BMI equals weight divided by age is square. So return return BMI coming. Yeah. So now I have this now. If a student, we have a student who want to calculate the BMI function. So it's going to ask me what is the weight. This is 50 kg in kg, and the height is 1.65. So automatically, this is the BMI of the student. So that's how to create. That's what a function does. Is to create an automated some stuff like that can perform all these libraries we use in our their function. The function do the behind scene work. So that's just practically what function does. If you want to create a function, we're going to write the function into a variable name. Then this is the function. This is the function body. We use this to create how we are going to get our mode. So we use
a quick question, please.
Function. Okay.
So that's creating a function that you just showed us. It's just like something arbitrary. We don't have anything to run that data, so we just keep it to know how to create a function. Is that what you're just doing?
Oh, I just showed you that so that someone will ask me, why do you create a function? This to explain what a function does.
Okay.
Yeah. So actually, now you know what a function does.
I have a question.
To create a function. Okay, I'm hearing you.
Okay, so with regards to this, now, is it possible to also create a function that can, like sometimes you want to regroup a numeric data into a categorical data. Let's say age, you then want to group them, like maybe from so age 8 to 9, like in SPSS, the way we do it. So is it possible to have a function that can regroup the data like this? I don't know whether you understand what I'm trying to say.
I got what you are saying. Probably we have this age and want to group this age into segments.
Yes, categories. Yes. You want to group age into categories. Is it that you are gonna create create a function that will do that? Let's say
you don't need a function. You just only need to use a logical function, like a logical statement. Please, we have 2 questions. Just hold this question to the very end of this class, please. Just note your question.
Okay, sir.
So we really need to move fast so that we won't spend much hours trying to without we should spend much hours of our time on what is very, very light to just get. So now this function, we created the function get model. This is the function. It's going to require a value called v, and we create another function and we created another variable name, we assigned another name to another unique function to this variable name, to this name. Somehow this name, let me just use this name. So this means unique. So, and we wrote this. So you can run this at your hands. You can just run this function at your hand. So once you run this function at your hand, you can see now you can use this function. Now you can use this function. So once you just say get mode of RDS age. So it's showing us that the most we have most occurring age in that data set is 35 years. So among those doctors, almost most of them, like the most frequent age, they are 35. Most frequent age is 35. So you can also write your value this your value, this your mode value into a function, into a object name. You can write it into an object name, which is result. You can write it into result, assign the value into result. So it won't display anything until when you press. Let me just results to get model RDX into it. So it won't display any value until when you call out the result using the print function, print RX, or you just write result. Just write results. So you're going to have it. So let's move to proportions. Let's move to proportions. Let me check this data set again so I can get the proper one to use as example for this proportion. As perfect example for this proportion. So we have names of RDS. So marital status. Yeah. Let me use marital status. Let me use marital status. So you can get the number of frequency first. The number of frequency by using table. Just table. I said I'm going to use okay, marital status, right? So into function, marital status. So can you see? It's showing us that 1, 2, 4, and others. So this one might be single. These two might be married. This one might be divorced, and this one might be widow. So it depends on how you code your data set. Actually, it depends on how you code your data set. Depends on how you code your data set. So this is showing us that, let's just assume 1 is single, 2 is married, 4 is divorced, while others is, let me just say, widow, all this stuff like that. So it's showing us that in the data set, majority of the resident doctor are not single, they are married. Majority of the resident doctor are married. Mustafa, you are raising your hand. Okay, it's showing us that majority of the resident doctors, they are married. Majority of the resident doctors, they are married. So these are the frequencies. Actually, if like your data set, they are not code, they have their proper qualities, like single, this is how it's going to appear here. It's going to appear like that there. So let's go to obtain proportion. You calculate your proportion from frequency. Yeah, that's to calculate proportion is the actual frequency of that group divided by the total number of observation. So your proportion, we are going to get your proportion from the table. So we have a function called, okay, let me just find the frequency first. I'm coming frequency of RDS of this marital status. Then this is the frequency, right? You will now wrap it up into a function called prop function dot table. So it's going to show you the proportions. So you can see that the married doctors actually have more proportions than any other one. And you can go other way around and say, okay, my table, since you have your frequency of RDS of marital status, you can write it into an object. Just say marital. marital. You can write it into an object. Once you write it into an object, you just say prop of marital. So you are going to get your proportion. So if you want to get your percentage, it's just multiplying your proportion by 100. That's just what it does. So, and this your proportion, you can control the decimal, the number of decimal. You can say digits. We have the digits equals, I think, to, does it work? Oh, so you can't control your proportions. You can only control your percentage. So this percentage is just for you to just multiply your proportion times 100 times the prop table. You can write this your proportion. You can write it into another object. So the general idea is just for you to just times it times 100, and you can control the digits. Probably you want it to be 2 decimal places. Say equals to 2 decimal places. What's happening? I'm coming. Oh, sorry. Okay. I can see the problem. Oh, sorry. What was happening? I'm coming.
I think it's the spelling of marital.
Oh, thanks. Okay, so I have this. So you can wrap everything. And if you want to control, if you want to control the decimal, sorry, there is something we call round function. You are going to use the word round. Yeah, round function. So in that round function, we have digits. Yeah, equals. Even if you have a function you want to pass, once you just type the beginning of the function, it's going to suggest. So digit equals to. It's going to bring them into 2 decimal places. You can say digit into 4. It's going to bring them into 4s, into 1. So as the case may be, you can use that too for this proportion, round. You can use that too for this proportion. Just say digits equals 2. So that's how it works. That's how it works. So I think, okay, someone is, Jamila, you are raising up your hand. Please, can you go on? Your question, please.
Yes. Well, thank you for the presentation, but I'm lost. I downloaded the Excel from the classroom, but I failed to get it to the R Studio.
You don't do what?
I downloaded the Excel from the classroom, that one that you are using for the presentation, but I failed to import it.
Okay, the data set actually is, I'm using the resident doctor data set. So you can get that from the classroom. You have?
I did. Yes, I have it.
I think the issue is how opening it on R on R.
Oh, opening it on R?
Yes.
Okay. Sorry. Are you sure you are in the right directorate?
Yes.
Okay, can you just do something? You are with your system, right? Just like pass the comment GT working direct GTWD into bracket and copy the output. I mean this, just say GTWD this, and copy the output, this output. If you can copy this output and paste it in the what are they calling it, in the chat box. Yeah, paste it in the chat box. I'm going to send you back a code that is going to load the data set.
All right, thank you.
Yeah, I'm expecting that. So I think we can continue, right?
I have a side question.
Okay.
Can you just let us view your code when you were trying to round up and multiply by 100 the proportion table?
Okay. This is the code. Okay, let me just write. I'm coming. Let me just write the proportion into objects so that you can understand the proportion of marital status. Yeah, let me just write it into objects like proportion of marital. So I've written it into objects. So it will now be 100 multiply by proportion of marital status. This gives the percent, like the percentage. So you will now pass it into a function called round. So you can write this one into an object, percentage underscore marital.
Thank you, I got it now.
So once you write it into, you paste it. Once you write it, write percentage of marital. Then you can control the digit like that. So you can control the digit. Let me check this.
Please, I have a question, sir.
Okay, you can go on.
Thank you very much. So if we want to run this function, like for example, if we want to use the mode, because I'm not using the R markdown, I'm just using my normal coding. You understand, the console and the coding field. I mean, I don't know.
I understand.
So how do I run the function? That's where we write the codes. It can only allow one line of code, so everything has been going smoothly. But I wanted to try the function, multiple lines of code to run at once. It's even though I highlight it and I click run, it's not working. It's saying not found. So
Wait,
how
I'm coming. Do you see this is how you are going to go? You are going to go about it. I'm coming one. So we are going to first copy the first line of code. Like, okay, let me just type it from scratch. Get mode. We are writing it into a function body v. Once you click this, R is going to write plus. That is expecting, he knows there is something that is going to follow this. There is something, he knows there is something that is going to follow this first line of code. So UB equals unique V. So once you click, it's still going to tell you plus because you have not closed the bracket. I don't know if you get. So that's how you write all. That's how you are going to write comments so that we won't waste our time. Let me just copy it. That's how you're going to write all the code. So after writing all the code, you paste. After pasting, you still write plus because you have not closed. So once you close it, you can now write your get mode, whatever you want to write.
Wow, thank you very much.
So you're welcome. So I think we can move on now. So now what about when you have multiple, like you want to check all the descriptive qualities. You want to check the number of variables, you want to check the number of missing, you want to check the percentage of missing, you want to check mean, you want to check standard deviation at once. Sorry, I'm not going to run this for you. Let me just drop all this stuff. Let me just drop them here. So for standard deviation, we're going to use LV. For variance, we're going to use VAR. For mean, the smallest value, you are going to use this. For maximum, you are going to use this. For which one again? For quantitative deviation, you're going to use, I think for percentile, you want to check your 25% percentile, 50% percentile, your 75% percentile. So you are going to check this. I'm going to use this. What else again? What have I not mentioned? Range. Is there anything like range? Yeah, you're going to use this. So please always remember to remove Rn when you have a missing value. Always remember, please. So now we have the function. We have a library. We called the TableOne. We have a library we called TableOne. A library we called TableOne. So you can check your R. Once you check your R, you can check here. These packages are these third quadrant. You can check the packages. Coming, is loading. But you can just check by typing. You can just search TableOne if you have the okay. You can just type TableOne and see if you have the TableOne. So I have the TableOne installed already. If you don't have it, you can install it by using the install.packages. So then you will install it. So once you install it, so in this TableOne package, we have a function we call the create TableOne. This is the name of the function, create TableOne. You can actually seek help from R by putting question mark. So it's going to give you what the packages entails. It's going to tell you what the packages entail. You're going to see vars, you're going to strata, data, fact vars, include any test, all this stuff. So you can come here and come and read. Please, please, can you just off your mic, please? So wherever you see vars, that means the variable to be summarized. We have structure. Structure means the grouping variable. Yeah, the grouping variable. This include any. If it's true, that means it's going to include any in the data set. If it's false, it's going to omit any. So there are many other documentations you have to go through in that TableOne. So you can just check at your own pace. You have TableOne. Not going to. So you can install TableOne by using install packages into bracket TableOne. So once you hit it, it's going to install if you don't have it. So I have it already. You can use the library function to load TableOne. So I want to use this our RDS data set. So okay, this RDS data set. So no, I'm going to create a vars. That is, I don't want to check all the whole. Okay. I don't want to check audio variables. I want to check for only age. So I'll say age. I'm going to write it vars into age. So I've created an object called vars. So coming to my create TableOne function, create TableOne, it's going to ask me, the first thing it's going to ask me, which variable. Once I say vars equals vars, comma, strata, I don't have any, I'm not grouping it by anything. So I can omit that strata. Data is going to ask me that where is that variable? Where is that variable coming from? So it's coming from the RDX. So if I click here, so it's going to show me the mean and the standard deviation. Can you see? It showed me the mean and standard deviation. So let me include that structure function. So, but we won't specify anything. So won't specify anything. So this structure means if you want to group the stuff by another variable again. So this include any is false. That is, even if there is any in the data, it should not include any. So once you write this into a function, like let me just say table 1, Yeah. And you run this. Once you run this, and you come here and say summary of table 1. So can you see? It's going to show you the variable name. After the variable name, it's going to show you the number of observation, the missing value, percentage of missing, mean, the standard deviation. Can you see it's round up the mean here, the standard deviation, the median, the 25%. That is 25% of the resident doctor half age equals to this or lesser than this. Why? This shows that 75% of resident doctor, this 75 percentile 75, this 75 shows that 75% of resident doctor age is equals to this or below this. Why 25% is greater than this or equals to this. So we have the mean value, we have the marks, we have the skewness and kurtosis. So that's how it works. Any question before I move on? Any question before I move on?
Yes, please.
So can you please go with your question, please?
Yeah, that verse that verse, when you're assigning age to verse, like I don't really get it, please. Like the table 1 function generally.
Like assigning age to verse is like telling, I'm just saying, okay, I'm coming. Let me go this way again so that you can understand. I'm just making the work easier for myself. Let me just say table 1 equals verse. I'm coming. I've never tried this. Let me just try age, but I think it's going to work. Structure equals comma data equals RDS and include NA equals false. Can you see? It works. It's just like I don't want to come and input this data set here, this age. I don't want to come and input it in this function. So I just want to like have the object and inside the object. That's just what I just did. That's just what I did over there. But here now like this.
Age.
You said?
Is age a data set?
Age is a variable in the data set. In this
is age a data set? Is it a data set?
Resident doctor data set. The age is a variable in data set. Is a variable, like a variable in this RDS data set.
Sorry, can you hear me? Can you hear me?
I can hear you. Check. This is age. Age is not a data set, but it's a variable in this data set. This data set we are working on. This resident doctor data set we are working on. So
I thought if you are mentioning a variable, you're going to use RDS $age. I thought you should use RDS $age.
Do you know this one I will not use?
Right?
Okay. Do you know this one I will not use RDS $age? Is that there is a function in this R. There is a demand in this creatable 1 that is asking for data. Which data are you working with? In which data can we find this variable? That's why I specify data equals RDS.
Okay. I think I get that now.
Whenever you have a function that is demanding data, that data, which data are you working with? You don't need to to use the $sign anymore. Just specify the name of the variable and assign the data to your data name.
Yes, thank you.
So now we want to, we have written our table 1. We have written our table 1 into, we have written our table, this data set into table 1, right? We have written it into table 1. So, but as well, you can, okay, let me do this. I'm coming. Let me do this. That person asking that if you want to summarize 25 variables or so like that asks that question. I hope the person is still on call. You can actually summarize more than one data set with this. So by coming this way, which data set do we have again? That is which data set do we have again? Which data set do we have again? Which
status, we have workload.
Oh, thanks very much, ma. We have, let me just come here and just copy this. Let me see if it's a copy. If it's a copy, let me just do for work load underscore SOS. Score. So this once you have, so you have already specified all these vars. Now you have like save all these variable names into objects called vars. So once you run this and you summarize, you see it's going to list all the variable names here. So I think we are good. So that just like, so the person can just, that your 132 variables, you can just put it here and just summarize them at once. So we can move forward.
I have a question.
You can
Is it all that we are doing towards this summarize and variables and TableOne? Is it because we loaded that package?
Exactly, it's because it was based on that package. Without that package, you can't work with create TableOne.
Okay, I also want to confirm that package, is it TableOne as in number 1 or ONE?
ONE.
Okay. Thank you.
So now if we know we know the particular, like we want to get if we want to get a particular measures that we are interested in, we are going to use the print function. Actually, the print function. We're going to use the print function. So once we use the print function, you pass in your TableOne. So you use non-normal equals to C, you close it. This. Once you run this, you are going to get only the mean and the standard deviation. And you can equally get only the mean and the standard deviation by only coming. This one coming on. Sorry. Once you do this, you can get only the mean and the standard deviation by just running this without summarizing it, without looking for the summary. If you just run it like this, it's going to show you the mean and the standard deviation of every. So, but when you pass all these commands into R, you can check for help, print, to check the meaning of all this function we have used. So once you read the documentation, you can know what those functions what they actually does. So we don't have much time. This, once you run it, it's self-explanatory. It's self-explanatory. So once you just run it, you're going to get the mean and the standard deviation. So what about if one of your data sets, if one of your data sets is actually coming, just do it like this. If one of your data set is not normally distributed, when a data set is normally distributed, that's when you can use mean and standard deviation as basis for information. But when it is non-normally distributed, we are going to use the mean and interquartile range. Let's assume our age in this case is non-normal. So in this non-normal function, we are going to specify that age is non-normal. So once you run it, you are going to see that in age, it's going to tell you that it's calculated the mean and interquartile range for the age alone. The rest is going to bring the mean and the standard deviation. The age is going to bring the median value and interquartile range. So please, do we have any question? Any question, please? So in the absence of no question, so we are still going to use our TableOne function and the data we are using. So let me use this this gender. Actually, this should be gender instead of female. This gender as example. So this gender, let me check the structure of RDS underscore female. So it's integer actually, and in my own coding I want 0 to represent male and 1 to represent female. So I'm going to say RDS of this female. You're going to write this as you are telling how to treat this as character. We talked about this in the first class. Yeah, as character. So it's going to treat this as character. So now I want to check. I want to treat the age and the gender, which is saved as female. Sorry for that, female. So is it? Why did I run into? Problem? No value. I'm coming. Why did I run into problem?
We should have run the variable before we create it into table.
Coming. I want to check something. Coming. Okay.
Is data supposed to be?
Oh yes, thanks very much. Thanks for that. You can see that's a very sad thing about R. If you are not very careful, I've gone backward. If you are not very careful, Jesus, R can disgrace someone. That's just it. Age. I said I'm going to use age and what? And female, right? Female. So running this data is equals to RDS. So yeah, thank you very much for that. So we are going to have we have one discrete variable, one qualitative variable and one quantitative variable. We're going to see it's going to summarize them into batches. Can you see this is for the age and this is for the what am I saying? This is for the categorical variable. So you will notice the difference. Just once you code your variable, you are going to have it in your mind. So we have an assessment. This assessment, you are going to do it at your own pace. I don't think I can run you through the assessment. Let me just introduce you to this. This is what I use more often. I have something I called library of what? What is even this function? Jesus, I've forgotten this one. Library of, what's the name of this? Okay, summary true. You can just, this one is just additional. You can just load this summary true. This summary true. Summary true.
Yeah. Load it as a package.
You said?
Is it a package? Is it a package or we just load it?
It's a package. Yeah, it's a package actually. Okay. Packages, summary true. If you are connected to internet, you can just do it. So actually, this can actually do those works we have been doing since. I don't want to load it. I have it already. So let me just call the function. So it has the function called DSR. So if I pass RDS into age, so can you see the result? It's going to bring this result. It's still the same thing we have been doing since morning. It's going to bring this result in this format. If you want to check for a qualitative data, just say frequency, R. So freak. So once you check freak of what, RDS of what, of 8 categories, you're going to see the frequency, the percentage, and everything. Once you want to check for what, okay, cross tabulation. Let me just say cross tabulation. C frequency, I think, yeah. Is this C table? Yeah, C table of RDS underscore, let me just say cat and RDS underscore gender, which is female. So it's going to bring it this way. So it's just like additional stuff. So you can run this assignment yourself. You can run this assignment yourself. So I'm going to like skip this assignment part. It's still the same thing we have been talking about since morning. So just
please, what's the name of the tool again?
Summary tools. Summary tools. So now we are going to data visualization. Let me just go straight to data visualization. So
he said I said why could he say that summary tools not found?
You will first install, you will have to install summary tools first. You have to install it.
And that's what I did, and it says summary tool not found. Install packages.
Are you sure? I'm coming. Where's even the stuff?
Is there in the packages? I install it now.
Okay.
But you have to tick it. You have to search it and tick on it again after installing.
Okay.
I'll install it.
I'll do it again.
After installing, you have to load it in by using the library function. So I made mention of something in our first class about the base R, like the base R and probably installing additional packages. The base R, what the base R does? The base R can do anything, but you have to you'll be an expert, a pro in R before you can use base R effectively. Yeah. Packages, because base R is going to stress you, but packages, there are some packages, there are thousands of packages, if not even millions, that has been provided by experts to just make work easier. So we want to plot the histogram of age, of RDS of age. So this is the histogram of RDS of age. We are going to pass the variable name into a function called is, HIST, is RDS underscore age. So you are going to have it displayed this way. So change the name, the title name to be main, to be main. You can actually use the help function to read about histogram on her. So if you want to check the title of the histogram, let me just say histogram of age of resident doctors under studies, in brackets, coming in brackets, years. That is, the age is in years. So once you run it, you're going to see it's going to display at the title. So once you use the main function, so you can use, once you are using the base R, I'm talking about the base R now, you can use xlab like this, yeah, to change the name at the x-axis. This is x-axis, this is x-axis, and this is y-axis. This is x-axis, and this is, so you can use it at the x-axis. The x-axis name to be the age, yeah, age. So you're going to see it's going to change. You can change the lab at the y-axis as well. I think you can pass color, color function to be red. I think Why? Let's move on. It's not working. So you can actually read. Let me try to read the histogram function. Come on, let me read the help. Let me see how it's. Oh, okay. Okay, sorry. I missed the function. I knew it has a color. I knew it has a color. The color function is used, like the color function is COL. Sorry, not color. COL, red. Yeah. So you can change the color. You can change it to blue. Can you see? We have it. We have it. So, so that was all. So I want to plot two variables together. Two variables. That is, I'm plotting the okay. This is not a cool example. Let me use age. So I'm plotting. This is the scatter plot. I'm plotting the age of the resident doctor against their workload score. Their workload score. You can see this is a positive correlation. There is a positive correlation between them, but it might be very weak. So you can use the function color to as well to change it to blue, to red. Okay, you can change it to red. You can give it a title, just the same way. Give it a title, scatter plot. You can give it a title. So they can change the y-axis and the x-axis by using xlab. Xlab equals work load score, comma ylab equals age. So it has changed. So that's it. But if you want to cost, because R is very, 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 very beautiful. If you use R for visualization, it's very, very beautiful. Like you will see the beauty of R when you use visualization. So we have to load a library called ggplot. Is it ggplot or ggplot2? Yeah, ggplot2. This is the library name. ggplot2. ggplot2. So before we move to this, any question, please? Are we cool? Like, is everybody cool?
Yes, I am.
Okay. Yeah.
Okay. Thank you.
So now, going to ggplot2. Before we start, just load ggplot2 by using the library function to bring in ggplot2. So we want to replicate the same set of graphs we have made in the above what are they calling in the above. But you can still write this graph. You can write it into name, so into objects. You can say this is plot one, or okay, let me just say this is scatter plot, scatter underscore plot. You can write them into functions so as well, into objects, sorry. So once you write it into objects, you can write it into objects. So you can write them actually into objects. You can write them into objects. So once you write it into object, just say scatter plot. It's coming. I think there is a problem somewhere. Why is this not writing? But actually, you can write, probably the base R can write into objects, but I think you can write into object. You can write into object. So if we want to consolidate our graph, we have what we call ggplot 2. So please, I want you to take this very, very important. When we talk about ggplot, in the ggplot package, we have something we call ggplot2 package, we have something we call ggplot. That's what we call geometric plot. That's the full meaning, geometric plot. We call it ggplot. So ggplot is going to take set of arguments. Yeah, call them arguments. So it's going to take the data arguments, one. It's going to take the aesthetics arguments. That's two. The data argument and the aesthetic argument. So, and in that same packages, we have something we call geometric. Geometric, for every geometric, there is different arguments for every geometric, but they might be very, very similar. So let's start. The first one we plotted is what? Is histogram, right? Is histogram. Just say, okay, ggplot into which data are we working with? You can say data equals RDS. It has sequence. After RDS, we have, because this histogram it wants to show the distribution of the age. So it's going to take the argument called in this aesthetics x, that is the x-axis. The x-axis is what? Is age. So plus geom. Okay, plus geom what? What do you want to plot? Do you want to plot geom bar? Do you want to plot geom box? Do you want to plot geom this? Do you want to plot geom this? So I want to plot geo histogram. So I want to plot geo histogram. Once you click this, can you see what happened? Can you see what happened? This is what happened. This is what happened. So in geom histogram now, there are sets of arguments you can pass into geom histogram. There are sets of arguments you can pass into geom histogram. So let's go. Fill, that is, I want the color. Just observe, I'm coming. Observe this color before. This is the color bar. Just observe this color. Fill. I want this color to change to blue. Can you see? To blue. It has changed to blue. So I want to increase. Okay. When after changing to blue, I want it to be very light, not too deep. Not too deep. I'm going to use the argument called alpha into 0.25. Can you see? It's very light. Very light. Once the higher the alpha level, the deeper the color becomes. Can you see? The deeper the color becomes. So what other argument are we adding? We can add, okay, the bin width. The bin width. Like we want to widen the bin width equals 10. Can you see? It's going to increase the size of the bin. It's going to increase the size of the bin. It's going to increase the size of the bin. What other arguments? You can say color. You can use the function called color. Color equals, let me just say red. Can you see? At the tip edge of the bins, it colored it red. It colored it red. It colored it red. So that's how ggplot works. So something about ggplot is that it uses the normal English. So what about why customizing your labs? Like you want to give ggplot label, you're going to use the function labs. So I won't talk about these things again. Yeah, I won't talk about these things again. So please note, if you want to connect another variable, probably you want to create a scatter plot between the workload of between age and their workload sum, and you want to group them into with the agenda. You want to separate them with the agenda. So in every geometric, we are going to use aesthetics to connect a variable to a particular function. I'm going to show you that. So this lab is meant for giving your graph title, subtitle, caption. So once you click on labs, you have the title is going to bring title, my graph. Let me just use my plot. You see, it's going to show. You have subtitle, histogram. So it's going to show the subtitle. You can put y as on this one now. You are not using x lab. You are just going to say y equals frequency. Yeah, frequency is going to display, and x equals the age is going to display. So you can put a footnote called caption. You can put a caption. Actually, you can write a whole lot of grammar. Probably source of your data source equals start clinic library. So it's going to show here. So I hope I've talked about the labs, because subsequently I will not talk about the labs anymore. So you have plus. You can still add what again? Okay, we have the teams. We have teams. Actually, you can say team classic. Let's say team classic. Can you see? It's going to check the teams. We have different kind of team minima. I love this. This is what I use most of the time. Team minima. We have team black or team dark, as the case may be. Team dark. So it's going to change the background to be dark. You can even install external teams. Yeah, you can install external teams. Team minimal, team replace, team updates, team void. We have team void. You have team void. So we have different kind of teams. So you can install external team actually. So it's still going to do the same work. So now I've talked about this. I've increased the bin width. So let's experiment something with this bin width. This bin width. Let's change it to 30. Okay, 39. The higher the bin width, the higher the size is. Let me just change it to. Let me just leave it to like 2. Let's just see. Can you see? The size is like, it's going to like spread. It's going to show like a couple of bars. The higher the bin width, the bigger the size. The size actually. So I've talked about this. So I've talked about the teams too as well. I've talked about the teams. So now. Let me go back to our example. I'm trying to use this example as this one as coming. So now we can like calculate the mean of this. Okay, the mean on the graph, we can calculate the mean by using the word you can add two geometric together. I'm going to show you that vertical line. So it's going to ask you something. It's going to ask you x-intercept, that is the value of x, which I can pass in the mean of RDX into bracket age. I hope it works. Does it? Let's see. Yes, it works. Yeah. I can pass the mean. I did not know the actual mean. I can pass in the mean. The line type, I can change the line type to be the line type to be dotted line. Line type should be dotted line. I can increase the size of the line type. The size by using size argument equals, let's use 1.5. So I can change the color. The color equals red. Color equals red. So you know something? Whenever you pass your geometric function like geom bar, geom scatter, any argument you are passing into that geometric is actually for this new geometric you pass them into. This attribute now will not work for this geohistogram because I pass the argument into vertical line. So I hope you are cleared. So you can label, you can add label to it, you can add label to it, you can still like do plus geom label. Once you say geom label. Do you know why this one did not label? Because actually I did not get the mean of coming. Okay, let me actually. So if you use the word geom label, this is 35. So this might probably be 34 point something. Yeah. So you can get the value of your mean. I think it's 34.12. Yeah, from the initial point. What about on the axis? If this is 10, this should be the mean should be. Let me just put it on 30. Let me just put it on 30. We're going to specify. Why is it not working? Okay. This should be, I said something 34.12, right? Is loading. Okay. Yes. This should be what? Another 30. So can you see? So it shows that yes, this is my mean. It shows that this is my mean. It shows that this is my mean. So please, I hope, are we clear on this? Any question?
Yes, sir.
Any question, please? Okay.
Are we going to have this command? Are we going to have all of these commands for practice? Can we have like the RNG?
Okay, you want me to send this particular one to you?
Yes, it's better so that we can use this data and run it and be proficient in it.
Okay. No problem. I'm going to send this. I'm going to
recorded message, but the RNG file or something.
Yeah, I'm going to send it out. So now I think we can move forward. So we have there are many functions. Let me just tell you the gospel truth. The gospel truth is that I can't teach all this. Like I can't teach all this stuff. I can't teach them. I can't teach all in this class. I can't teach all these functions or like all these ggplot in this class. So you have to do your personal discovery by using what we have, this stuff we have given, this what are they calling it? By using this the material we have, the resources we have actually given, you can actually find you can add your median if you actually want again. Zoom V line intercept. Okay, S intercept equals median of what? Median of RDS into bracket age. If you just pass it like this, It's going to automatically find the median. Can you see the median? This is the median. This is the mean. So I just have to just show that. So let me just tag this one. Let me just tag it histogram. So let's continue. I have to paste this. So what graph next? I'm coming. I want to look for the next graph. I can work. Okay, let me show you density. Yeah, density function. If it's density function, the only thing you have to just change. The only thing, instead of using geom histogram, it's going to be geom density. Yep. Once you use geom density, so part of the function of geom density, bin weight is not part of the argument. Yep. Bin weight is not part of the argument. So you can delete all these labs. You can delete them. So this is. Wait, did I even know what I'm doing? I'm coming. I deleted the wrong stuff. So
I was going to say that maybe you should just copy and go and paste it somewhere else so that you don't delete the things you've done already.
Yes, that's what I want to. Okay. Do you know what is happening? I said something in the first class that R is irrespective of the space you gave R. R is going to capture. Because I added plus here, it's adding this last command. It's adding this last command. So yes, this is what I want. This is geodensity. This is density. This is density. So density. Let me just put it here. Density. So you can still perform the same function by changing the function, by changing the you can change a lot of things. Density. Yeah. Yes. So what about if you want to plot density and this thing together? You want to plot density and histogram together for age. Density and histogram together plus age. I was telling you that you can plot two geometric function together. Let me delete from here. So this is actually our histogram. So we want to plot density plus density equals aesthetics. Y equals ... I think y equals ... density. Oh, we run to I'm coming. Y equals ... What's now the command? Like I forgot the command. I'm coming. There is a particular command for that. I think it should be density. Yeah, it is density. Why is it now? Density. Coming. You're right. Coming geom plus geom density. Yup. Okay, so we've gotten it. Yes. So when you wrote your ggplot data, you specify your data, your aesthetics, X is age, Y you want Y to be density. If you did not specify this, let me cut this away and let's see what it's going to bring. It's going to bring only your histogram, no matter how, even if you specify your geom density. So once you click, but once you put this dot density dot at the Y argument, and you put your geom histogram, then you come again and put your geom density. It's going to run a density for you alongside your histogram. So you can pass the color argument into the density function. The color argument, you want it to be what? To be yellow. To be yellow. So you can do a lot of things, sha. You can try a lot of things by increasing the size. So I hope you are good.
Yes,
Yeah, we are trying to be good, but we'll be better if you help us to put all the hashtag and send it as an RMD for us to do hands-on.
Okay. But the general idea is that you understood the basic concept, right? That's the general idea.
Yes, sir.
So let's try what are they calling it? Let's try this scatter plot. Scatter plot. Scatter plot. We have, okay, let me just use ggplot. What is my data name? Equals RDS. I might not even write this data name. I can just put RDS, AEX, X equals age, and what Y equals work load sum plus geom point. Yeah, point. Once you first run this, what's happening?
I think it's workload underscore.
Workload underscore sum. Oh, thank you very much. Yep. So we have this. So once we have this, you can what? You can say color equals to red. You can do a lot of things. So can you see? So you are giving a color. You can change the color. You can. What else can you do? You can rename you can just perform what you have done in that first graph. You can replicate it again. You can replicate it in this graph again. You can replicate it in the second graph. And I was saying something. Okay. Let me just copy this. Okay, now we want to know we want to check the relationship between the workload and age with respective to the agenda, So you are going to come to this geom function. You are going to pass aesthetic. Okay, aesthetics. Okay, you can just like you can connect your color function. This aesthetics take color function. You can connect your color function to be what? To be let me just say, okay, to be female. Yep. So it's going to tell you that, can you see, this female actually means gender. It's going to tell you that 0, in this data point, wherever you see orange, it means male. Wherever you see 1, it means female. So you can see that the highest workload score is earned by a male counterpart. Why the lowest? is end by what? Is end by a female counterpart. The highest age, the highest gender, the gender with the highest age is a male too. Can you see? The gender with the lowest age, is also a male. So can you see? So that's just the decision. That's just the decision. And if you don't want it in this way, let me just use this opportunity to do this. I'm coming plus grouping with colors. You can use shape too as well. You can use shape. It takes something we call shape too. Shape. You can use shape. You can connect shape to your variables. So another variable in that data set. Can you see? When you see cycle, it means male. When you see a triangle, it means female. Okay, let me just connect this shape to their children, so that you can understand very well to their children. Why is it taking it years to load? Or did I miss the variable name? Is it children? Yeah, it's children. It's children. Okay, let me just use age category just to be in a safer side. Age cat. Yes. So you can see it's going to bring the key. Can you see? Showing you the age category. So that's how it works. And faceting. We have something we call faceting. Let me just copy this and just bring it here. You can do this for any of the geometric. You can do this for any of the geometric. Faceting. So let me just clean this. As I'm looking geo first. I can just say facet wrap. We have this facet wrap function. This like approximation of what? Age cat. Can you see? It's going to splint everything. It's going to split them into groups. Actually, this ggplot is like the foundation. This ggplot is as the foundation. Why these are the layers? And if you just put any geometric function here, any geometric function below, it's going to inherit this argument, all this argument that, oh, bro, we are working with this data, we are working with this aesthetics. So, or else you have contrary argument. That's when you can pass it into the new geometric function. So we have something we call facet grip tool as well. Okay, let me just leave this. Let me copy this. Just copy this and just put facet. Let me just change this to facet. Is it grid? I think it's grid. Facet grid. Yeah. See, it's going to like put everything in a row instead of in columns. So you can still label them. You can merge two. You can actually merge two data together. Two qualities together. Sorry, two qualities together as well. You can merge two qualities together by this, and you add plus. What can I do? Let me just use that they are female. Let me use that they are female. But it's much more better with wrap. Yeah, it's much more better with wrap. Yes. So you will have it. It's going to show you this age for female, this age for male, this age for female, this age for male, like that. So I think you can as well increase the size of the point. You can increase the size of the point if you wish. You can reduce the deepness by you can do a lot of things. I just want to rush this. I think we are 2 hours plus. 2 hours plus. So using
I have a question. If we do a scatter plot, for example, maybe their workload and the age, can we do what we call a line of best fit, like we do for SPSS?
Exactly, man. That's a very nice question. I forgot that. Let me just come. Let me just come. Let me just copy this one. Yeah. So once I copy this one, let me just clean this one. So we have a function we call geom line. See geom line? Oh, sorry. It's geom smooth. Geom smooth. Yeah. Yes. Can you see? Can you see? So you can
yes.
You can do it by coming. I keep cleaning this thing. You can do it by adding your geom plot. Can you see? So if you don't want this confidence interval, you're going to say SE equals, I think it's false. Does it work? Yes. SE equals false. So we have method. If it's a linear, if it's a linear, you can use linear. So it's going to make a linear. If you want a generalized additive model, you can use this jam. Am I right? I think it's jam. Yeah. They are much. So you can just check. You can just check on your own. You can check on your own. We have laws. I think law is too as well. If I get it right, we have them. I did not get the right pronunciation. Let me check. Let me check the documentation. Let me check the documentation. So R is your friend. You can check for documentations so that you can methods. Okay, methods. It's by seeking help. You can check for documentation by seeking help. So you can check for documentation by seeking help. I'm coming. So I've seek help. I've checked under the method. The method we have generalized linear model. Yes. So can you see? We have the generalized linear model. We have the Ctrl Z. We have the generalized additive model. We have them many. So you can do a lot of things. We have them many. That's just this. We have them many. So you can just on your own. You can just once you just keep trying. Once you keep trying, you are going to get it. So let's go to bar chart. So we have a prepared stuff already. Okay, bar chart. Let me just use ggplot to construct the bar chart for you straight up without wasting much of our time. Bar chart. So okay, ggplots into bracket data RDS, comma AES into bracket x equals age cat, comma y equals age. That is, if we have y equals, I don't want to use age, work load underscore sum. If we have, let me just say, if we have two variable, which one is qualitative and one is quantitative? So I'm coming. Geom bar. Okay, don't we have geom bar? Here is a problem somewhere. Did I miss any variable name? Workload sum, score, yeah. Age category, yeah. What is happening? Okay, I'm coming. Oh, yes. I can see the problem. I'm coming. Let me first start with this. So, using our existing data
what
set.
was the problem?
I'm coming. Using our existing data set. So, y-axis is the count, y-x-axis is the age categories. Can you see?
So it means we can't have two variables.
You can have two variables. I just want to explain this. You can have two variables. So you can still perform change your color, change this, do that to this same function. So I won't waste time on that. Let me just move forward. So when you have two variables coming, let me just copy this. When you have two variables, comma, y equals age, right? Work load underscore score. So we are going to pass into this geometric start. We have something we call the start function. We are going to write identity. Without this identity, it's not going to do this. So it's going to tell you the workload score and the age, the corresponding age, having the workload sum, the workload sum score. So can you see? So you're going to pass the word called identity. So you can still add faceting to this one too. Faceting, you can do a lot of stuff. Faceting by what? Let me just say faceting by gender. Let's see female. Let's facet by female. So can you see? It's going to tell you one to male, one to female, and this stuff. So I think we are cool, right?
Yes.
Okay.
Yes.
Let me just come here. So can you see? You can still do you can label it. You can give it title and all this stuff. So you can give it title and all this stuff. So let me just come and do this pie chart. Let me copy this from here. I want to do everything in a single. Oh, sorry. I want to do everything in a single file, actually, in a single chunk, so that when you see it, you understand it.
Single document.
I don't want to do it. Yes, I want to do it in a single chunk. Pie chart. So we actually created this. We have slice. And we have this variable. So we want to plot our pie chart using the something about this stuff. This ggplot, it does not have a function called geompie. Does not have, so it can't plot pie chart. Probably there is another way around. I don't know. So you are going to use this function. You're going to use this. So we have this data set. So I'm coming. Let me try something silly. I've not tried it actually. Let me just try it. We try something about programming is that you have to keep trying. RDS. I'm coming. Okay. Let me try something. I'm coming. Coming on. I want to try something. Library. Tidyverse. Coming. I want to try something because RDS percent mutates. Okay. Group by what? Group by each cat. Yeah. 10%, summarize, n equals n. Okay, let me write this into a variable called p. I'm just trying into a variable called p. I just want to try something. Okay, pi into brackets p underscore n labels equals, what are they calling this thing? Labels equals p underscore hcards. Oh, yep. Yes, I've gotten what I want to try. This is the very first time I tried this. Don't worry, I'm going to walk you through this the next class. This is how to plot your pie chart. So this is how to plot your pie chart. You are going to once you have, this slice is like the frequencies. Okay, what I did earlier is like I have to calculate the frequencies, like the frequencies of this stuff, the frequency of these age categories. So I wrote it into a function and I pass it into pie chart argument. P $, the frequency, and label is called age category. So that's how I get this age category. So I can give it title. You can give it title as well using the base. Because we're using the base, we're going to use mean because pie chart. So yeah. So show you the number of frequency, the rate at which each category of age occurs. So that's what it was. I think that's the last. So someone asked a very intelligent question during the course of the lecture. He said, if we have a missing value, how do we know we have a missing value? Please, are you still online? Like the person that asked this question, is she still online?
Yes, I'm still online.
Oh, that was good. Oh. Without teaching you the stuff, coming on, I want to see how. Okay, please, can you do me a favor? Like, can you do me a favor? Can you just please attend? Can you just please attend the next class? Because I've wasted most of our time. There is a particular set of stuff I want to I have it in mind to teach after this class. Like, let me just say 20 minutes briefly. In that particular set of stuff, that's when you are going to learn how to filter your data. You're going to learn how to filter your data, how to do some stuff. So the next class, I promise you to answer your question.
All right, no problem.
So I know it's a very bad idea to procrastinate. It's very bad to procrastinate, but I beg you to procrastinate this to the next class, so that even the larger class can have access to this thing I'm about to talk about.
All right, no problem.
Please, any question generally.
I want to say concerning that, it would be good for you to help us to probably create a facade data that will have missing data, because sometimes when we go into all these databases for secondary analysis, we may meet this missing data often, and we will need to be able to navigate around them. And then my other request is that kindly help us to clean this tonight's teaching, so that at least when we are working on it on our own with the hashtag, we'll be able to do, because we're doing so many things together and we may want to replicate it in different form. For example, do the histogram, put the line diagram or the density one within it, and then do the scatter plot, then put the line of best fit and all of that, so that we will be able to, it will be reproducible. Thank you very much. I appreciate it.
Okay, I'm going to do that. I've taken that. I've noted that. So, like, I really appreciate your time. I do sincerely appreciate your time. I've taken much of these classes, like, for 1 hour, and the scope of this class is to give a solid background. And I can't just come and pull everything down. I'm actually concerned about your knowledge. I'm actually concerned about your knowledge. I hope with this few time we spent together, I have been able to impart even more little knowledge about R. So thank you very much. Thanks for your time. We do sincerely appreciate. We appreciate it.
When should we be looking forward to receiving your this on the class work?
Let me just say tomorrow morning, because I will have to. Let me just and work on it. So if I have anything I want to add, I'm going to add it so that you can work with it as well.
Okay, thank you. We'll watch out.